Hello, I am Dr. Jacob Schrum, an associate professor of computer science at Southwestern University in the Department of Math and Computer Science. And among the various computer science courses I teach a course on artificial intelligence, which is also my main research area. So, been thinking about this question of, how is AI going to change our lives? How is it going to impact society? And basically, AI has already changed your lives. It's all around us. It's kind of a moving target. Researchers in the field have struggled over time to define exactly what AI is. And the public perception has also shifted over time. There's a lot of things that you enjoy every day that you may not think of as AI, like Google Maps uses search algorithms to plan perfect routes. In the early development of AI, we thought, oh, this is really fancy, this is difficult. But now that computers can do it so well, we sort of don't even think of that as AI anymore. And so we move on to other things. And so we have things like your Facebook feed and your YouTube recommendations that, suggest videos to you. And we call these things, the algorithm. But what kind of algorithm? Well, they're machine learning algorithms. Massive amounts of data are taken, processed, and analyzed to learn patterns and make predictions that will achieve whatever goal a corporation has in mind, whether to get more views, earn more money. But that's machine learning, and that's AI too. But of course, what most people are thinking about with respect to AI right now is generative AI, where we have AI systems that can generate new content, whether it be art or text, based on massive amounts of training data. Major examples on the art side are things like Mid-Journey, Stable Diffusion. And then on the text side, we have ChatGPT, and other ones like Gemini from Google, which used to be called Bard, and Claude, so from Anthropic. So there's various models out there, and there's lots of independent third-party ones that you maybe haven't even heard of as well. Most of the major advances in modern AI that you've heard of depend on something called neural networks. Now, these have been around forever. In fact, a neural network is technically the brain. Our brains are the original neural networks. What AI uses are what are called artificial neural networks. But models for neurons have been around since the 40s. Now, they weren't really using AI back then, obviously. AI models of neurons came about in the 60s, and neural networks were used heavily as far back as the 80s. But we actually hit a wall. There was what is known as an AI winter, where people worked really hard with neural networks, thought they had reached sort of a ceiling on what was possible with them, and then most people kind of gave up on using them and moved to other approaches to AI. The nice thing about research is that you can focus on whatever your passion is, and some people just really thought neural networks were the way to go, even though most of the research community had moved on. And given time, they eventually discovered a few clever tricks, and also some advanced hardware came along that allowed them to overcome the limitations that seem to exist with neural networks. The emphasis is on it being an artificial neural network, so we're not trying to necessarily capture the full complexity of the brain. A lot of it can be described mathematically, where we have various inputs, which in a computer, it's just a number. Everything in a computer is a number. So we have numeric inputs that are traveling at what are called synapses. And so you might have kind of a neuron, and you have inputs, which are these synapses. Different inputs come along those synapses, modeling roughly a neuron in the body, in the brain. We multiply the inputs by the weights to determine the strength, and those get aggregated here and then transmitted. And you may think, well, what does that have to do with AI? Well, impressively, if you take a lot of those, combine them together, you'd think that all you get is a mishmash of numbers. Numbers in, numbers out, what does that mean? But clever algorithms can train the weights on these networks to manipulate the incoming signals in very specific ways to do very intelligent things. And there's some argument that maybe there's some similarity to how this is done in the brain, but there's also kind of an argument of, who cares if it's similar to the brain? Let's just do what works. And if it works, good. And even if we don't understand it, fine. All we care about is results. So your standard example of a machine learning classification task that might be done by a neural network would be, can you recognize a picture of a dog from a picture of a cat? And so you give it tons of pictures of dogs and cats, and you say, this one's a dog, this one's a cat. You train it by adjusting those weights. That's a process called backpropagation that's usually used. And hopefully, if you do this with enough example inputs, it will learn to correctly classify new inputs it's never seen before. That is supervised learning because the person training it knows what the answers are in advance. However, a lot of modern AI depends on unsupervised learning. An early important advance in this sort of unsupervised training are known as generative adversarial networks, which is something I've done a lot of research with personally. The first example was generating, fake celebrity faces. So the idea was you look at a bunch of celebrity images, you don't tell the algorithm anything about them, you just say, here are faces. And then what the generative adversarial network, or GAN, does is it learns to generate fake faces. So, human-looking faces that aren't actually real people. Now, we've moved beyond that to the ability to generate images based off of text inputs. So we still have to have massive amounts of data to train these models, and we're still using neural networks along with various other tricks. We're also trying to get some sort of numerical representation of what words mean and how they associate to images. And so we can take lots of raw text and embed it into what's called a latent space. From a mathematical perspective, it's a vector space, but it's basically turning words into long lists of numbers. And what's crazy is that the way that we train these models makes it so that the properties of these numbers and how they relate to each other have meaning. So like a word embedding can solve analogies, for example, where if you take the numeric representation of man and the numeric representation of a woman, and then the numeric representation of the word king, you can subtract the man from the king, add the woman vector to it, and the output will be the vector representation of the word for queen. And the fact that this works at all, at least a good portion of the time, is kind of shocking, and leads to a lot of the power of these models. And you may think, how do they do that? Well, they're just absorbing all of the ways in which humans have used words, have used images in vast amounts of data that's on the internet. And so it's unsupervised in the sense that we're just taking the raw data and assuming it contains meaning and contains information that can be used to train these models. And we get a lot of benefit from doing that. So because these models pull data from all over the internet, there are concerns about plagiarism, copyright, whether this is legal, whether it's ethical. Are people's works of art being stolen? Are people's hard work in generating news stories and other sources of literature, is that being stolen? And there's an argument being made that these AI models are reading and viewing other works of art or human production and being inspired by it to create new things. And then there's the counter argument that no, they're just sort of taking it, copying bits of it, reorganizing it, essentially plagiarizing. There's pretty good arguments on both sides, and there's ongoing lawsuits. We'll see how they go. The power of these models is such that it's hard to imagine that we're not going to just keep using them. Hopefully, we'll find ethical, fair ways to train them that compensates creators and artists while still getting the benefits of these models. But that is a future issue that we'll have to wait and see how it turns out on.